Welcome to the Center of Excellence Lab, Schneider Electric. Here we are going to work with an industrial automation. Okay, industrial automation is nothing but you might have already learned in the theory part. Now we have given a real-time execution with the students project. Okay, so in the student project we are going to control a induction motor, because in industry 80% we use only the induction motors. So we should control that induction motor either remotely or manually or automatically, whatever the operation. So we should do it in an automatic way that student has tried in their project and they have executed it. So here we do have the kit and we do have the program and we do have the PLC kit and we do have the hardware circuit here. So we are supposed to control it remotely, that we are going to do it. Okay. So here everything is controlled by means of these contactors. So contactors in the sense it is a switching device, electromagnetic switching device. We are executing the program and we are just transferring it to the electromagnetic switching device so that it is going to operate. So in this video, so we have done a program of a forward and reverse control of an induction motor, because forward and reverse is an important application in industry. For example, in a chemical industries, to mix the two chemicals forward and reverse, it has to rotate. And also while talking about the paint industries for mixing of colors, and many we can take. Otherwise a simple, very good example in domestic application is washing machine. So here you can see to and fro movement with some time delays. So that we are tried here. Okay, so for that we have done a ladder logic diagram with a time delay. For example, the time delay is 10 seconds, and now I am going to transfer the project to the PLC, from the PLC, from the system to the PLC. Okay, because I have an accessory to do the program in the system. The system uses the Unity Pro software. In the Unity Pro software, I have done the ladder logic diagram with a timer. All are inbuilt timers inside the PLC. I have not used an external timer in the hardware circuits. So students have tried only the contactors with the hardware circuits and programmed them. So here we have all the ladder logic symbols. So they dragged and dropped in the Unity Pro software. After that they run the program, so they transfer the program to this PLC and they run the program. The beauty of this experiment is I can control anywhere. Okay, for example, I want to control from other system in this lab, I can control. So this is the remote controlled operation. Okay, so now we can see the demo regarding, or we can have a detailed explanation of the hardware circuit. So here we are going to see the controller board for this induction motor. We have already done the program in the ladder logic and we have the forward and reverse control. It is not specific that we should use only forward and reverse. We can do it for any application. Only this is the hardware structure which is required. In PLC we can change multiple programmings. So here we have given the RYB as the input supply in this side and we have taken the RYB as the output side. So for this application, I have given one of the phase in the reverse direction so that it will run in the forward and reverse alternatively. So here we have two contactors. For the two contactors we are going to give the control voltage from the PLC. So actual control is the PLC. So here we have the two terminals A1 and A2. Here also we have A1 and A2, which is connected to the PLC input. So that we will get the connection and I am going to operate it. Now I think I will operate it remotely from that system so that you can see the real-time application. I am going to operate the three-phase induction motor remotely by sitting here. Okay. So I have done all the application in any of the system. I can transfer to any of the PLC connected. Now I am going to operate from this PLC. As the student's ladder logic is already done here. So I am going to switch on remotely from this bench to there. So this is the added advantage, and this may be the initial stage of the SCADA. In SCADA we might have learned that from anywhere we can control the motor in the work area. So similarly, from sitting in this system, I am going to operate there. So it is actually, you can view the motor over there. It is in the stationary position as of now. Now I am going to give the control signal. After giving the control signal, the motor will run in the forward and reverse direction alternatively. So the time delay I have given may be the 10 seconds. So it may be manipulated also. Now I am going to give the control signal to the PLC. So I have given it. You can see there the motor is first running in the forward direction. So the time delay given was 10 seconds. Now I have changed it to reverse connection. Here, control I have given. The motor is trying to run in the reverse direction. So this process is cumulative and this operation is the automatic operation. There is no human interference in it. So just give on-off control from my system and I can see that automation is achieved. So by means of the hardware circuit by sitting here and I can control. So this is one of the example as a student's project. We can do anything with this. So I can control by this HMI also I can able to control. So many added advantages are there that we can do from this industrial automation. Yeah.